Hi and hello. In this next lesson, we're going to cover two more centers of a triangle. They're called the circumcenter and the incenter. Before we define those two terms, we're going to touch on a couple of old definitions again. We're going to revisit what a perpendicular bisector is and what an angle bisector is. So let's start with the perpendicular bisectors and the circumcenter. Remember, the perpendicular bisector of a segment is a line that creates a 90-degree angle and divides that segment into two congruent parts. A while ago, we talked about the perpendicular bisector theorem. It says that if a point is on the perpendicular bisector of a segment, then it's equidistant from both endpoints. So here in this diagram, we have point S is on the bisector of segment QR, so that means S is the same distance from Q as it is from R. So SQ is equal to SR. Similarly, point E is on the other end of the segment, but E is still the same distance from Q as it is from R, so QE is also equal to RE. So let's see this in action. Here we have segment AB and a perpendicular bisector, line DC. This means that point C is the same distance away from A and B. It's equidistant from the endpoints, so AC is equal to CB. This lets us set up an equation. 4x minus 5 is equal to 3x plus 2, and then we can do a little bit of rearranging. We can subtract the 3x over, we can add the 5 over, and it simplifies down to x equals 7. Alright, so here's how it ties into what we've been doing. The circumcenter. The intersection, or point of concurrency, of all three perpendicular bisectors is called the circumcenter of a triangle. So here's a quick demonstration of finding the circumcenter. The circumcenter theorem says that the circumcenter is equidistant from all vertices of a triangle. This is true because it sits on each perpendicular bisector. Because it sits on the perpendicular bisector of BC, it's going to be the same distance away from B and C. And because it sits on the perpendicular bisector of AB, it's going to be the same distance away from A and B. So if we call our circumcenter I, this tells us that AI is equal to BI is equal to CI. Now, the reason we call it the circumcenter is because it's the same distance away from each vertex, we can actually draw a circle around the triangle such that it doesn't cross through the triangle, but it still touches every single corner. Regardless of how I move the corners of this triangle around, it's always true. The intersection of the perpendicular bisectors is the center of a circle that circumscribes this triangle. It's the circumcenter. Now let's use these properties to solve a couple of problems. We'll use the same diagram for each. For example 3, if we have ZG is equal to 65, HL is equal to 63, and ZL is equal to 16, we can fill these numbers in and identify where HJ and ZJ are. Now, because ZL is a perpendicular bisector to HJ, that means that HL has to be exactly half. So we can just double that. HJ is 126. Now, point Z being the circumcenter means it's the same distance away from all of the corners. So ZG is the same as ZH is the same as ZJ. ZJ has to be 65. Let's check out another one. In this next example, we'll fill in new numbers. If ZM is 25, ZH is 65, and GJ is 120. Well, GJ being 120 and M has to be the midpoint because, again, ZM is a perpendicular bisector. So GM is 60. MJ is also 60. Now, we touched on this idea on the last problem. If Z is the circumcenter, it's the same distance from each endpoint. So if ZH is 65, then ZG also has to be 65. Alright, so now that brings us to angle bisectors and the incenter. Remember, an angle bisector is a line that goes through the vertex of an angle such that it splits it into two congruent halves. So if a point is on the angle bisector, then it's equidistant from both sides of the angle. Because C is on the angle bisector, that tells us that AC is the same length as CB. Just a real quick example. Here we've got point M that's on ray KM, which is a bisector of angle K. Because JM is 12.8, that means LM is also 12.8. Which brings us to the incenter. Just like the circumcenter was the intersection of all three perpendicular bisectors, the incenter is the intersection, or point of concurrency, of all of the angle bisectors. So let's call this point I. Because point I is on each angle bisector, that means it's the same distance from each side, which lets us make a circle on the inside of the triangle. This is called an inscribed circle, where it just touches each side but does not actually cross any side and is fully contained in the circle. And the center of that circle is the incenter. So that's the last of our 4 centers of a circle. The circumcenter is the intersection of all the perpendicular bisectors, and the incenter is the intersection of all of the angle bisectors. Thanks for watching.